All right, here we go. So we're talking here, all right, about vertical asymptotes. Let me grab these. Vertical asymptotes you guys are always better at. Tomorrow we're going to go over the horizontal asymptote ones, which I know we get confused with a little. So we'll refresh our memory on those rules and stuff, because vertical asymptotes are a little easier, right? All right, so here we go. A vertical asymptote is a break in the graph. Pretty simple, right? When the function, right, we know that, right? It's a break. When the function increases or decreases without bound, we talked about that. That's the infinity thing, right? Increasing to infinity or decreasing to negative infinity. So anytime we have that infinity idea, as x approaches a real value c, are we good, you guys? Okay, I'm starting here. Thanks. You're on video too. You gotta they're gonna hear you. So before, right, we talked about that we would just write does not exist when we had this infinity, negative infinity. So now we can actually say infinity or negative infinity. And then it therefore is going to automatically imply that there will be a vertical asymptote at x equals c. So whatever this c value is here, by definition, by default, it has to be that there's a vertical asymptote there if I am going toward infinity or toward negative infinity, okay? This is a really important concept here. Be sure you understand that the equal sign in the statement here, when it says equals infinity, does not mean that the limit exists, right? The limit still does not exist. On the contrary, it tells you how the limit fails to exist. So this is still a DNE, right? But it's just explaining it's a DNE that is an infinite limit, okay, by denoting the unbounded behavior, right? So it still doesn't exist, but it is giving us just more information and showing us that it can be infinite or negative infinity. So let's refresh our memory on how to graph. So I want you guys to graph these three. So you've got 1 over x minus 1, got 1 over x minus 1 quantity squared, very similar, but how are a and b different? And then again, another similar one, negative 1 over x minus 1. How are all of these different? So just go ahead and do a quick sketch, graph-orama. Let's see how you would graph those three, and then we'll talk about infinite limits. Where are their asymptotes for this one? At positive 1, right? So we look at denominator. Denominator always gives us our vertical asymptote. So you should have vertical asymptotes for all of them, right? At x equals 1, x equals 1, x equals 1. They all have that same vertical asymptote. Do they have x-intercepts? Any of them? All right, there's no x-intercepts, right? We get x-intercepts from the numerator, and since there's no x up there, there's no x-intercepts, which means what's happening at our x-axis? You have a horizontal asymptote here. And again, we'll refresh our horizontal asymptote rules tomorrow, but it's not a bad idea to remember when the numerator is smaller than the denominator, it's always at 0. So we've got horizontal asymptotes for all of these at y equals 0. None of them have x-intercepts. What about a y-intercept? Where would my y-intercept be for this one? Plug in 0 for x. What do you get? Yeah, so your y-intercept would be at 0, negative 1. And that can give you the first curve. And then where's my other curve going to be over here? Top or bottom? Top, right? It's going to be an opposite. We good? Yes. Right? When the degree of the denominator is odd, it's a first degree. That means odd means opposite. They go in opposite directions, right? You could always pick a value if you want over here too. Pick a 2. 2 minus 1 is 1. 1 divided by 1, right? We're positive. All right, so that's my first graph. Simple. We should all be able to graph that like in less than 5 seconds. How about this one? How does it change? What does it mean when that denominator gets squared? Yeah, it means positive. It means everything's positive, right? So it means that this branch that was before down here at negative is now going to flip up and be positive. This other branch doesn't get affected. And so now instead of having a reciprocal graph where you've got sort of opposite quadrants here, they're both going to be going in the same direction, right? The exponent of that denominator is even. Even always means same direction. All right, how about this one? That negative 1, compare it to A with a positive 1. What is the negative 1 going to do there? It's going to flip it, right? It's going to flip everything. It's a negative in front, means it flips the whole thing. So instead of being upper right quadrant, this is going to flip upside down, and this one's going to flip up here, right? And so what I'm going to look like is this. Yeah, just little transformations. Okay, so we should be able to do those graphs pretty quickly. But now let's talk about, we've got a vertical asymptote. Okay, so it's very clear that there is this vertical asymptote here. And so as x approaches 1 from the left, so as I'm approaching this vertical asymptote from values of the left, what am I going toward down here? And we're going to put negative infinity, okay? Because it's going down, 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 down. That's going to be our negative infinity. How about from the right? Positive infinity, right? Because I'm going up, 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 up. So these are going toward positive infinity, whereas these are going toward negative infinity. Does that make sense? So where in the past you would say DNE, instead of doing DNE now, we want to be more specific and tell us what's actually happening, okay? How about this one? From the left, where am I going? Positive infinity. From the right, positive infinity. So this one, if it did ask you for an overall limit, since they're the same, and it just asked for x is approaching 1, right? It didn't have right or left of g of x in this case. I could say positive infinity since they're both going toward positive infinity. For this one, this would still be a DNE overall because it's different from the left as it is from the right. But again, if they're the same from the left and the right, we could still continue to say infinity there, okay? How about this guy? From the left, positive infinity, and from the right, negative infinity. So I think once you guys have the graph, it's pretty easy to see whether it's going up or going down, right? But it's creating those graphs is something that we got to refresh your memories with, okay? It was chapter 4. I know it's been a while. All right, let's try another one. So this is the same equation, x squared minus 3x over x minus 1. And I want to show you that you could do it either graphically or numerically and kind of get this idea, right? So let's start this first one graphically. So we can factor, right? X minus 3 over x minus 1. There's no whole, but I do have a vertical asymptote at x equals 1. So let's do a graph here. This guy does have some x-intercepts. Where are my x-intercepts? Well, right here, this would give me an x-intercept at 0 from this first one. And I'd get an x-intercept at 3. All right, how about a y-intercept? Well, plug in 0, 0, 0, 0. What do you get? 0. It's going to be right here, same thing, right? So I have a y-intercept at 0, 0. Horizontal asymptote. Quick little refresher. Degree of the top is 2. Degree of the bottom is 1. It's top heavy. Top is bigger. Oblique. This is an oblique asymptote. We love oblique asymptotes. Do some quick synthetic division. This is easy. We'll do more of this tomorrow. Quick synthetic. Here we go. 1, 1, negative 3. 0. There's nothing there, right? 1, 1, negative 2. This is my remainder. You do want to put the 0 in as a placeholder there. So I don't care about my remainder. So oblique asymptote, that's not hard. is x minus 2. Makes sense then, right? So I'm assuming my graph does something like this. Okay? Good little refresher. And we'll practice in example 3, just finding vertical asymptotes, okay? So what are we supposed to be finding? The limit as x approaches 1 from the left. So as I'm approaching this vertical asymptote of 1 from the left, what's my solution? Well, it's going up, 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 up. Answer is positive infinity. I don't even have any space in there. All right, but it's going up to positive infinity. So that's how we do it graphically. Again, you have to remember your rules to graph this, though. You got to remember your horizontals, your obliques, your verticals. You got to remember all that. If you forgot those rules, or if you're not 100% sure, you're struggling, you can also do numerically. Okay, so what do I mean by numerically? Well, I want to find, oh, I guess I was supposed to find both of these. From the right, then, obviously, with our graph, right, we can see that it's going to be negative infinity because it's going down from the right. But what do I mean here by numerically, choosing values from the left and from the right? Well, what you would do is you would pick values that are close to 1 from the left and close to 1 from the right. So it's kind of like doing, your table, right? At 1, I know it doesn't exist, but it's something like 1 point, and if you have a calculator, this is easy. If you don't have a calculator, you might want to pick other values, like just pick 2 and 3 and 4. Right? And pick like 0. Well, this is going to be even harder. It'd be better to do decimals, right? But if you don't have a calculator, you can just do numbers like this. And what you're going to see is which way are these numbers moving, right? As I plug in these values, what am I getting? So go ahead and plug those numbers in. And what you're looking for is it going up or is it going down? What am I getting here? 4 plus, so 10, negative. Is that true? These look right? What's this? 2, 4 minus 6, negative 2 over 1. No, that's not right. It should be 0, right? And then 3. Oh no, I did that wrong. That was at 2. 3 was 0, right? So this was good. What was this one? Negative something? Negative 2? What was 4? 16 minus 12. 4 over 3. I don't know. Are those right? Help me out here. It's Monday, people. It's been a long weekend. It is negative 1, negative 2. I don't know. Is it? What'd you get? If I do negative 1, it'd be negative 1 squared minus 3 times negative 1 over negative 1 minus 1. So that'd be 1 plus 4. No, 1 plus 3. So 4 over. There it is. So that one is okay. But they could be wrong. I just was doing these in my head quickly. So what am I looking for here, right? I'm trying to see what's happening to my numbers as I'm getting closer and closer to 1. I'm at negative 10/3, then negative 2, then 0. Are these numbers going up or are they going down? Yeah, these numbers are going higher and higher and higher, right? So they're going up. So from the left, I'm approaching positive infinity because these numbers are going higher. Over here, 4/3, 0, negative 2, these numbers are going down, and so from the right, I'm going toward negative infinity, okay? If you had a calculator, you would obviously type in decimals, and you would see really closely how big those numbers are getting. You would do your, 1.0001, 1.01, etc. The graph, I'm going to tell you, is going to be a lot easier. So if you can remember your quick graphing rules, I think it's going to be a lot quicker than trying to plug and chug. All right, so speaking of graphing, go ahead and determine all vertical asymptotes for those graphs. Let's see if you remember your vertical asymptote rules. Vertical asymptote for letter A. Vertical asymptotes, you should write x equals for each of these. So go ahead, x. Tangent. Come on, you guys, don't you remember where your asymptotes are? That's one of them. Where are the other ones? That's two of them. Yeah, how do we write that? I don't know what's going on. Really well, to be honest. All right, let's go through our vertical asymptotes on this one. Last part here. So the first one was you got no problem, x equals -1. For this one, it does factor into x plus 1, x minus 1. Nothing cancels. So each of those is going to give me vertical asymptotes at plus or minus 1. Tangent. Remember? Yeah, so you're going to have asymptotes at pi over 2. And negative pi over 2. Here's your tangent graph, right? Yeah, but then remember, it repeats. So then I have another asymptote, right, at 3 pi over 2. And I have another asymptote at 5 pi over 2. So how did we write that? In this case, it's actually just pi k, but you get the right idea. It's actually plus pi k. And then we do the little asterisk and we say where k is an integer. So why is it just plus pi k? Because this repeats, you're looking at the distance between each of these asymptotes. And that distance, or that period, is just pi. So I'm just adding a pi, adding another pi. If the period was 2 pi with like sine and cosine, those have a period of 2 pi. Remember, tangent only had a period of pi. All right, this last one, I kind of tricked some of you. You told me it was plus or minus 2. But if you factor, it's not. Because if I factor this numerator, what do I get? X plus 4 and x minus 2. And then down here, I have x plus 2, x minus 2. So one of those x minus 2 becomes what? A whole, yeah. So this one becomes a whole, and therefore it's not a vertical asymptote. And I only have a vertical asymptote at -2. That's it. Okay, that's it for notes today. So what I want you to practice, tonight's homework is very specific. That's it. You're only doing, I think it says it on the, I know it says it on the answer key. Look on page 33. You're only doing numbers 3 through 18. So you're going to start down here on page 33. And again, it's saying just find those vertical asymptotes, so just like we just did on each of them. And you can check on the calculator, but try and find them by hand. And then go all the way through to 18 on the next page. Okay? You have a couple minutes if you want to get started. And that's it.
We're not doing example 4, 5, 6, 7.
Tomorrow.